Bobby Fischer was once quoted saying that chess is life. Even though he didn't mean this in a literal way, it must be said that there are several strong correlations between chess and life. First, we must imagine that every person's life is like a game of chess, with a doctor on one side and a disease or death on the other. While each game of chess is unique, the pieces and patterns remain relatively constant. The same can be said of medicine. While every individual is unique, the proteins and patterns associated with each specific disease remain relatively constant.
Since the early 21st century, large genetic studies have been used to identify a large number of genes and proteins that can be associated with complex genetic disorders such as psoriatic arthritis. One of the problems with these studies is that identifying the most significant proteins within the large array of proteins identified can be quite difficult. One of the major proteins identified by some of these psoriatic genetic studies was a protein known as Act1. The goal of my project is to gather as much experimental data as possible regarding Act1 and how it contributes to the development of psoriatic arthritis. To identify all of the different proteins that are associated with Act1, I used some of these large machines behind me. These machines are known as mass spectrometers. They can identify different proteins within a sample at a microscopic level. Each of the machines has a different function. While one may be more sensitive and be used to identify different proteins within a sample, another may be used to quantitatively measure the different proteins within each of the samples.
However, as in chess, the reality of the treatment of complex genetic disorders is that while we are looking for magic bullet treatments, the inhibition of a specific protein or gene may not be worth the repercussions of the treatments. The only way that I believe we can begin to properly treat any of these genetic disorders is to fully identify and comprehend the roles of each of the major proteins or pieces.